Alright, so in this video we're asked to evaluate cosine of arctan square root of 3 plus arcsine of 1/3. And so I'm just going to go ahead and begin by rewriting this. This is really just the same thing as seeing something like this. So arctan is just another way to say tangent inverse, square root of 3 plus sine inverse of 1/3. And so what I'm going to go ahead and do now is make a substitution. So I notice that I have tangent inverse of square root of 3. So I'm going to go ahead and call that, I'm going to go ahead and call this guy right here A. And so that means that A is equal to tangent inverse of the square root of 3. And then if I rewrite this using one of our definitions, this is equivalent to saying, okay, well, tangent of A is equal to the square root of 3. And again, just remember that tangent, the quadrants for tangent fall between quadrants 4, or tangent inverse, I'm sorry, is between quadrant 4 and quadrant 1. And because tangent here is positive, then this is going to fall in quadrant 1. So if I make a small little graph here of quadrant 1, if we think about our angle theta, let's say theta. And again, I'm going to go to make a triangle here. Well, just remember that tangent is y over x. So again, this would be our y. And again, we can think about this as the square root of 3 over 1, and that would be our x. So the horizontal distance here would be 1, and the vertical distance here for y would be the square root of 3. And then again, our job here would be to go ahead and just, I guess, fill in or figure out what r is. And so we would have to use the Pythagorean theorem, and so we would say, okay, well, 1 squared plus the square root of 3 squared is equal to r squared, and so 1 squared is just simply 1. The square root of 3 squared is simply just 3, and we're going to get r squared here. Give me 1 second, sorry about that. Okay, so my apologies for that. So here we ended up with 1 plus 3 equals r squared. Again, 1 plus 3 is going to be 4, and then we take the square root. We're going to end up with 2, with r being equal to 2. So I'm going to go ahead and write that here. Well, that takes care of tangent. Now we're going to do the exact same thing, but we're going to do the exact same thing with this sine inverse of 1/3, and I'm going to call that b. And so that means that b is equal to, let's see, sine inverse of 1/3. Or we could just write this as sine of b is equal to 1/3. And again, sine of b, let's see, sine inverse of b falls between quadrants 4 and 1, I'm sorry. But again, this is positive, so that means we're going to be working in quadrant 1. And so again, we're going to go ahead and do the exact same thing that we just did right now. I'm going to create some angle that we're going to call theta. And again, some point there. And I'm going to make some triangle. And again, just remember that sine is y over your r. So again, our vertical distance here is 1. The hypotenuse here would be r3. And it looks like we got to figure out what our x value is. Now, if you do the Pythagorean theorem and you go through all the work, you're going to end up with let's see, x equaling the square root of 8. So again, if you use the x squared plus y squared equals r squared formula, you'll get this. But again, just cleaning this up, the square root of 8 is really the square root of 4 times the square root of 2. And again, square root of 4 is just 2. So x is going to give us 2 square root of 2. I'm going to go ahead and write that here. And again, I encourage you to kind of go through the process. Don't just take my word for it. Really just enter your y and your r and see if you actually get this value out. Okay, so once we have all these numbers in place, we come back up here and we say, okay, well, what are we trying to find? Well, we were trying to find cosine. We were trying to find cosine of a plus b now. So I'm just going to go ahead and resubstitute I guess the substitutions we made, right? So that would be a. And then we're going to have, let's see, plus, so let me go here, plus, and then whatever our b was, and b was that sine inverse of 1/3. And if you look at what we have now, if you look at this right here, this should look very familiar since we've spent so much time talking about this in class. this right here is our sum identity. And so what does this equal? So what does all that equal? Well, the identity is cosine of A times cosine of B minus sine of A times sine of B. And so we now got to figure out, okay, well, what is cosine of A? What is cosine of B? What is sine of A? Sine of B. In fact, maybe I should color code these things. Like for instance, when we talk about B, we're going to be looking at this pink triangle here, and when we talk about A, we're going to be referring to this blue triangle here. So let's go ahead and I'm going to go ahead and write over here to the left, because it looks like I have some more space. Looks like I have some more space on the left side. So first thing is first, I want to figure out, well, what is cosine of A? Well, cosine of A, let's see, cosine of A is equal to the, let's see, x over r. So if we look at this triangle, our x is 1 and the r is 2. So that's going to be 1 over 2. And if we look at, let's see, if we look at cosine of B, well, I'm going to write that here, cosine of B. Well, now we're looking at this triangle here. Cosine of B again is the x over the r, so it's going to be 2 square root of 2 over 3. So let me go ahead and write that here, 2 square root of 2 over 3. And then again, if we move on to sine of A, well, again, sine of A, let's see, sine of A, we're talking about this blue triangle over here. And so, let's see, sine would be the y over the r. So let's see, sine of A would be the y. That's going to be the square root of 3 over 2. And then, let's see, sine of B, that's going to be this guy here. So sine of B, let's write that out. We're going to look at the pink triangle here. And sine, let's see, would be the opposite, or the y, which is 1 over 3. And as I was doing this, I realized that maybe I should have labeled things a little bit differently. For example, this is really not theta. This should be angle B. And again, this over here is not theta. This is really our angle A. And so when I'm referring to angles A and B, those are the angles that I am referring to. Well, we have everything we need. All we have to do is just plug this in. So I'm going to go ahead and use, let me see, let me do this in white so it stands out. I'm going to go ahead and use this formula right here. And I'm going to go ahead and use each and every one of these values that you see here and plug them in. So let's see how this goes. So it looks like we're going to have it equal to, let's see, cosine of A is first. So cosine of A for us was 1 over 2. So we're going to have 1 over 2. Times cosine of B. Well, cosine of B for us was this 2 square root of 2 over 3. So let's see, 2 square root of 2 over 3. And then we're going to minus or subtract that. And let's see, next comes sine of A. Well, sine of A for us is the square root of 3 over 2. Square root of 3 over 2. And then we're going to have, let's see, sine of B. And sine of B is just this 1/3. And now let's just simplify this a little bit. And so again, we're just going to multiply straight across. So here we're going to get 1 times 2. That's just 2 square root of 2 over 6. Minus, again here, square root of 3 times 1 is just the square root of 3. And then 2 times 3 on the bottom is 6. And again, we can go ahead and leave our answer like this. Or we could go ahead and just write it as one fraction, which is, oops, that line's a little crooked. We could write it all over 6. And then in the numerator, we'd have 2 square root of 2 minus 3. And this right here would be our final answer there.